Welcome to part 6 of the Cubics and Quartics revision. This is the last question, a multi-part question, so we'll take a bit of time working through each of the parts of this. The following cuboid is made of 640 metres of wire. Firstly, we need to find h in terms of x. If we look at this diagram, we've got a 4x dimension, which is 4 of those. So when we're making up our equation, we need to have 4 lots of 4x. And we also need to have the x component, so there's 4 lots of just one x. And there is also going to be 4 lots of the h component. Okay, so all of those things there added together will equal 640. Okay, so I'm just going to rewrite that slightly differently. For each of these dimensions, so you've got the 4x along here, the x along here, and the h along here. There's 4 lots of all of those, as I just demonstrated. So the way I initially did it was we went 4 lots of 4x plus x plus h is equal to 640. Simplify that down, we have 4 multiplied by 5x plus h is equal to 640. Then if we divide both sides by the 4 at the front there, so divide that by 4, divide that by 4, that will cancel that down and leaves us with 5x plus h is equal to 160. And we're wanting to find h in terms of x, so we need to leave h on its own, move x to the other side, so we'll take 5x from both sides. That'll give us h is equal to 160, take away 5x. So that's the answer to the first part of the question here. I'm just going to shrink this stuff up a little bit. Oops, shrink too much of it there. I'll just leave it like that for now. So anyway, the first part of this is h is equal to 160, take away 5x. For the second part of this question, we're asked to find the volume V in terms of x. So I'll change the colour and I'll go into a different part of the screen. We use this one down here. So I'll come down the bottom here for part B. And the volume is length times width times height. In our question, it's equal to 4x multiplied by x multiplied by h, the height, which equals 4x squared times by h. But the question did say that we need to find it in terms of x, so we need to get that h out of there. What we're going to do is the h that we just found from over here, we substitute that. So we've got 4x squared, and where we see h, we'll substitute 160, take away 5x. And that will be equal to, if we factorise the 160 and the 5x, 5 goes into both 160 and 5x, so that's sort of the same as 4x squared multiplied by 5, and 5 times 32 is 160. And take away x, which will equal 4 times 5 is 20, x squared, 32 take away x. And that's the answer to the second part of that question. Okay, we'll move on to another slide, which will have a bit more working space for me. Okay, so this is the same question. So firstly I'll write the answers from the first two parts in there. H was equal to 160 take away 5x. That was for part A, and for part B, the volume is equal to 20x squared multiplied by 32 minus x. Okay, for part C, it wants us to find V when x is 11. So I'll go up to the top here. V, this is just our equation from the last part, it was 20x squared, 32 minus x, and it wants to find V when x is equal to 11. So we simply substitute x equals 11 into this. So it's going to be 20 times by 11 squared multiplied by 32 minus 11. If we punch that into a calculator, we will end up with 50820 meters cubed, which that's the answer to part C. Okay. Then if we move on to part D, find the possible values for x for the cuboid to exist. Okay, so what we need to do with that is basically consider what a graph of this might be, and we need to look for some x-intercepts. We're looking for the possible x values, and those x-intercepts are going to be the boundary, I guess, of where the cuboid will exist. So for part D, I'll use a different colour here. So for part D, what we need to do is we have our x-intercepts, will be when the volume is equal to 0. So we can take our equation from up the top there. So 20x squared, 32 minus x. So that's equal to 0. So from this part here, we get x equal to 0. Or from this part here, we get x equal to 32. So the limits that we're going to have, the graph will exist between those 2 points. The cuboid will exist between those 2 points. So we'll set this up as x, where we have 0, x, and 32. Now the question is asking for the possible values for the cuboid to exist. So we definitely know it's going to be like so, but is it going to equal? Well, if x was equal to 0, then the cuboid would not exist. So any minuscule fraction above 0, the cuboid theoretically can exist, so we'll need to just leave it like that. We can't let it equal 0 or equal 32. Okay, moving on now to part E. I'm going to do E down the bottom here, down here. For part E, it says find the possible values of x for when V is equal to 6,000. So what we need to do is set up our equation again. 20x squared 32 minus x, and set that equal to 6,000. Now I have to expand out that bracket, which will give me 640. Whoops. It's not a 6, is it? I'll rub that out. 20 times 32 is 640. X squared take away 20x squared times by x is 20x cubed. And that's take away 6,000 equals 0. And the question actually, when I wrote it, said give the correct values, or give the values correct to 2 decimal places. So it's not going to be a particularly easy thing to try and factorise. So this is where we pull out the graphic calculator and we use that to get a solution for this. So the steps we need to do, and I'm just going to bring in a photo of the screen capture that I took when I did this question. So here it comes. And by magic, there it is. What you can see that I've typed in, this is using a TI Nspire. I've typed in the function solve. Whoops, I don't want to push that around, I want to draw on it. We've typed in the function solve, and then the part that we have in the middle there is this line here. I haven't bothered with the take away 6,000, I've just set it equal to 6,000. But the important thing that you need to do to avoid any issues is this last little bit, you need to have comma x. So I've sort of drawn a little bit over that there, but inside that is a comma x, so it is really important that when you type it in you go solve, then you have your bracket, and then blah blah blah, whatever the function is that you're solving, equals, put an equals in there, blah blah blah, whatever that is, comma, and then x if you're solving for x, y if you're solving for y, etc. That's the important thing there. And here we have 3 answers. We've got a negative 8.5964, we've got positive 12.3588, or we have positive 28.2376. If we look at our cuboid, I don't know how you're going to get a negative length of wire, so that one there is going to be discounted straight away, and that will give us the answer of x equals 12.3, 2 decimal places, so 36, or 28.24. So they are the answers that we have for this one. Okay, we'll next move on to the next slide to answer the last question. Okay, on to part F now is where we're up to. Find the maximum volume of the cuboid and the x value where it occurs. So the best way to do this for you at this point in time is again to use the graphic calculator. So I'm now going to pull up a couple of diagrams with some screen captures of what I did. Now the one that we have here, whoops, what am I moving that for? First one that we have here is I've just drawn a graph and fitted the screen to it. So I've set the screen to negative 15 and positive 35 on the x-axis, and I took it up to a maximum height of 10,000 up the top there. And as you can see, the maximum is coming pretty close to 10,000. You can also see by the shape of the graph that where the maximum occurs, it's not actually quite halfway between those 2 places where it touches the x-axis. So unlike things like a quadratic, we can't rely on symmetry all the time with these, so we will need to go through a bit more of a process. When you do calculus, you'll be able to learn algebraic methods of doing it at this point, and now a calculator will do it really well for you and really quickly. So once you've drawn the graph on the calculator, you need to go into menu, and then you select analyze graph, and then you select maximum, and now I'll put in a couple more diagrams to show you the next steps. Now you can, once you've selected maximum, you can see down the corner here that it says lower bound. What you need to do with your cursor is identify where your maximum is, and then move your cursor somewhere to the left hand side of the maximum. You can see there's a little dotted line through there. And what I've done is I've actually scrolled to the left hand side of the cursor. It doesn't matter, to the left hand side of the maximum. And it doesn't matter where you go to the left hand side, so just somewhere to the left hand side of where the peak is. And what you do then is press enter, and then it will ask you for an upper bound. As you can see down there, it now says upper bound. The original dotted line we had there is there. If you scroll the cursor to the right hand side of the maximum, and that's what's reflected by this little shaded area here, and as soon as you go across you can actually see up the top there where it is identified the actual values of the maximum occurring at 21.3 and 9.74 by 10 to the power of 4. And when I checked that against the answers that was provided, I noticed that there was a little bit higher degree of accuracy in the answers. So I went into the settings and I changed the number of digits that would show on a particular answer. I increased it up to 7, I think that is, and went through that process again. So instead of having 21.3, it's given us 21.3334, which is basically 21 and a third. And it's also given us 97,090.37. So that means that the answers to our question is the volume, the maximum volume, is equal to 97,090.37, and it's in cubic meters. And the x value where it occurs, so that happens at x equal to 21 and a third. Okay, that's the answer to that one, and that's the end of the revision sheet. Hopefully you found this one useful, and good luck on your test.